This video is intended as an overview for experienced heating professionals. Refer to installation instructions for complete information. Always follow all safety precautions and good service practices.
This video demonstrates the diagnostic procedure to troubleshoot an oil burner primary control safety lockout. Let's do these preliminary checks first. Check the oil level in the supply tank. Make sure all oil line valves are open. Caution: disconnect power and examine the interior of the boiler for an excess accumulation of unburned oil. Restore to a safe condition before firing burner. Restore power and measure line voltage at the primary control input hot and neutral leads. You should have 120 volts AC. Less than 100 volts AC may cause operating problems. Caution: when testing electrical equipment, always observe standard electrical safety procedures. Before pressing the reset button, disconnect the nozzle line and reposition it to pump oil into a container. Tighten the flare connection at the oil valve discharge piping. Verify that there is a call for heat and the burner light on the digital manager is on. Now, let's press the reset button and observe operation of the primary control. Did the primary control pull in promptly? If not, or the control operates erratically, or not at all, jumper the low voltage B1, B2 terminals at the manager right-hand quick connect. These terminals connect the dry contacts inside the manager to the TT terminals on the primary control. If the control problem still exists, jumper the TT terminals on the primary control. If erratic operation continues, replace the primary control. If not, check the low voltage wiring between the primary control and the manager. Now let's check burner motor operation. Does the motor get up to speed quickly and smoothly? If the motor does not start, check voltage at the orange motor lead and neutral. If there is voltage present on motor lead, but the motor doesn't start, check for a locked rotor, tight fuel pump, tight motor bearings, low voltage, etc. For non-PSC motors, the centrifugal switch or thermal overload might be open. Locate the thermal overload reset button on motor. If popped out, reset and find what caused the overload condition. If there is no voltage on the motor lead, suspect bad primary control contacts or a shorted FF circuit. Remove a CAD cell lead from one of the F terminals and repeat. Now check the electric oil valve. Did the oil valve click open at the end of the pre-purge period? If the oil valve does not click open, check voltage at the violet valve lead and neutral. If there is voltage present at the valve lead, but it doesn't open, replace the solenoid. If no voltage is present, the primary control valve output is bad. Now check the quality of fuel oil delivery. Do you have a clear, steady stream of oil from the nozzle line? If the flow is weak or foamy, check the following. Vacuum gauge on oil filter. If vacuum is excessive, check for restrictions such as a plugged filter, strainer, or a frozen or dirty oil line. Foamy or weak oil flow may also be caused by suction leaks, loose fittings, weak pump shaft seal, single pipe overhead line, etc. If there is no flow, check the following. Loss of prime, broken pump coupling, blocked filter, blocked oil supply line, oil level in tank too low, defective fuel unit, closed service valve, stuck anti-siphon valve, etc. Now let's check ignition spark. While checking the oil flow, tip the igniter back far enough for the springs to lose contact with the bus bars. Is there ample spark? Do you hear the ignition arc buzzing? If no spark is present, check input voltage at the blue igniter and neutral leads. If line voltage is present, replace the igniter. If no voltage is present, the primary control ignition output is bad. If the igniter is good, Turn off the system power switch and remove the drawer assembly. Check the electrode setting, check the porcelains, remove the nozzle, and inspect the nozzle strainer. Check the retention ring or retention head condition. Reinstall the drawer assembly into the burner and reconnect the nozzle line to the drawer assembly. At this point, the burner starting operation has been checked. We know we have air, fuel, and spark present, but we have not tried to fire the burner. Begin with the system and burner power switches both turned off. Now turn on just the system power switch. Verify that there is a call for heat and that the burner light on the digital manager is on. Now turn on the burner power switch and let the burner try to light. Note, if oil leaks through the oil valve during pre-purge, the newer primary controls will detect a flame and lock out. Caution, if the burner does not light within 2 or 3 seconds after the oil valve opens, shut off the burner. Do not let unburned oil spray into the combustion chamber for the entire trial for ignition period. Repeat previous steps. If the burner fires and the primary control locks out at the end of the trial for ignition period, check draft over fire. If there is insufficient draft, the puff switch will open the FF circuit and will cause the primary control to lock out. Check the vent connector, chimney base, chimney cap, and boiler flue passages for blockage. If power vented, check power vent operation. Now check CAD cell condition. Check the CAD cell resistance while firing. It should be below 1500 ohms. If it's too high, check for a bad CAD cell wiring, loose CAD cell holder, CAD cell line of sight obstruction, etc. The emphasis here is staying alert. Usually you will be able to determine the problem by following the procedures shown.